Let's look at solving another absolute inequality. Remember, anytime we do this, we're going to make sure we isolate the absolute value first. So that's really key. If you don't do this, we end up getting the answer off. So isolate absolute value before you start. So that is done by subtracting 7 on both sides. So we should get absolute value of 2x plus 1 greater than 3 minus 7, negative 4. Next thing we're going to look at is try to understand, do we have an AND case or an OR case? And whenever we have the greater than absolute values compared to a number in the sense of the greater than symbol, we know we're going to have this OR case. So if we do this, we should have case 1. We can drop the bars, 2x plus 1, keep everything the same, greater than negative 4. Don't forget the OR. That's the nice link word. That's really important. 2x plus 1, that's case 2. Drop the bars. Now what happens here? We got to reverse the direction of our inequality symbol, change the sign of our number. So positive, it will be positive 4 instead of negative 4 because we started off with the negative 4. And now we're ready to solve both inequalities. So if we do this, you're going to isolate the x, subtract 1 on each side. We should get 2x greater than negative 5. Divide both sides by 2. We get x is greater than negative 5 halves. Don't forget there will be a link word. Might as well put it in now, the OR. And solve the other inequality. So we should have subtracting 1 from both sides again. 2x less than 3. Divide by 2 on both sides. X is less than 3 halves. So now what we want to do is we're going to look at what is going on with our graphs. So we're going to take a nice little number line. Plot your numbers or your boundary points in relation to each other. Maybe I think I'll stay consistent from the previous examples. Here we go. So x is greater than negative 5 halves. Negative 5 halves is going to be to the left of positive 3 halves. That's the first thing I always want to make sure with these boundary points. Greater than negative 5 halves means we are shading to the right and we have parenthesis opening up. I'll try to make that a little more profound for you all. And if we're going to graph x is less than 3 halves, we are shading to the left of 3 halves and we have a parenthesis opening up to the left wherever we've shaded. Now this type of graph could be confusing, like we don't know what to take unless we know what the link word is. So remember, because the link word was OR, we're going to take everything that we shade. So this is different. And would mean you take the intersection, but OR means anything that shaded gets to be the solution. So if you're kind of inspecting the graph, we've shaded everyone to the left of 5 halves, all the way through to 3 halves, all the way through to positive infinity. So even though we have parentheses in the situation, when you think about what the final graph will be, just so that we see, we don't really have to rewrite it as a final graph, but I want you to see, you really have shading all the way from negative infinity to positive infinity. So that's where our solution is going to be. And the reason why you don't really have to worry about the boundary points is because the shading from each graph covers up the hole that would be left from that parenthesis. So if you're looking at the 3 halves, even though there's a parenthesis at 3 halves, there's blue shading from 5 halves coming all the way through, covering up that hole. The same could be said for the negative 5/2. So this is why all real numbers would be the solution. Now, if you like procedures, stay with the graph. So as long as you know what or means and what and means, you can know that you're taking the right solution at the right time. If you would like a slight shortcut as far as analytically will go, I'm going to start from the 2x plus 1, absolute value of 2x plus 1 greater than negative 4. And just kind of think about it in terms of the heads up I always told you about is notice, remember, we have a negative number. And that tells you that there is going to be a special case. So it's a nice little heads up. And with the special case, a lot of people like to assume that the special case always is no solution, but this is not the case because you just saw us graph it. But let's talk about what this means. Remember, absolute value means distance. And when you're comparing distance to a number, we're saying distance is greater than negative 4. Well, if you want to talk about distances, distances are always positive. And if you're trying to understand what kind of statement you want to make, distance, because it's always going to be a positive number, it's always going to be greater than negative 4 at all times. It's actually always going to be greater than 0, right? Because always positive means greater than 0, and 0 is still greater than negative 4. So what we have here is a true case for all numbers that we would have plugged in for x in the first place, which is the reason why the solution is still all real numbers are negative infinity to positive infinity. So if you like that, go with it. If you kind of have a little more interpretation and you'd like to graph to see what the solution is, feel free to do either way.